Hello everyone. The question says, engineers refer to the time rate of change of acceleration as the jerk. The time rate of change of acceleration as the jerk. Assume an object moves in one dimension such that its jerk j is constant. So, the time rate of change of acceleration. This phrase here means the derivative of acceleration with respect to time is the jerk. Okay? This is the given information. Determine the expressions for its acceleration, velocity, and position given that its initial acceleration, velocity, and position are a sub I, v sub I, x sub I, respectively. Right, the subscript I refers to initial, so we are given the initial conditions. They are non-zero. The initial conditions are non-zero. We already solved this problem in the classroom, but let's just go over it one more time. We have to get three expressions, starting from the jerk, which is the derivative of the acceleration with respect to time. Where do you begin? This equation relates the jerk to the acceleration to the time. What are we trying to get to? We're trying to get to the acceleration cross multiply. When you cross multiply, what happens? You isolate dA by itself. Then on the right side, you have j dt. What do? You integrate both sides. So now this is moving to calculus. You should have taken calculus before, but if you did not take it or if you forgot it, it's totally fine. I cannot teach you an entire semester of calculus, but what I can do is I can just give you the results and you just have to memorize, okay? You have to memorize. If you cannot follow, you have to memorize. You integrate both sides. When you integrate dA, the answer is delta A. When you integrate j dt, so we have a rule. The rule says when you integrate a constant with respect to any variable, j is a constant, the answer to this integral will be j times t. Okay, which is why I put down here j times t. The j times t is going to move down in the next step. In the meantime, the delta is always final minus initial. So you have A final minus A initial. What do you do lastly? You just move the initial acceleration to the other side of the equation. Go to the next line, the final acceleration or the acceleration for all times. They mean the same thing. You're just using the different symbols. Is equal to jt. That was the term already we had. And the second term coming from the other side of the equation, which is the initial condition. This is the solution, everybody. Here we have the solution. And you have to memorize it for the upcoming exam. Then you have to determine the velocity. Okay, so without doing part A, you cannot move to part B because part B depends on part A. What is the fundamental equation that relates the velocity to any other quantity? We have the acceleration related to velocity. How? The change in velocity is your acceleration. So here we go. This is your starting point. You cross multiply. dv equal to a dt. What's the next step? You integrate. Once you integrate dv, you end up having delta v. You end up having delta v after integrating dv. Then on the right side, what do you have? You have to now integrate the acceleration. But acceleration is not just any acceleration. You have to pull it up from the equation you got above. Okay, so you plug in. How do you integrate now? jt and a sub I. So the integral you have to distribute. How do you integrate jt? We have a rule. The table of integrals will tell you when you take jt, and integrate with respect to t. J is the constant. It's a coefficient. You can basically take it out from the integral sign. Then t has an exponent of 1. The rule says you have to add 1 to the exponent and then divide it by the total number of exponents. In this case, what's the total number of exponents? 2. So what's the solution? Jt squared divided by 2. Jt squared divided by 2. How do you integrate a sub I? Another rule we have. Every time you integrate a constant, in this case the constant is called a sub I with respect to some variable, you're going to have the same constant remaining and you're going to put the variable t, which is why you have yourself here t. On the left side, when you have delta v, it's just going to be v final minus v initial, and then you can always take the v initial to the other side of the equation. So moving to the next step, just combine everything and clean up, right? The vi is going to go to the other side of the equation, 1/2 jt squared plus a sub I t. Finally, determine the position. How do you determine the position? What is the equation that relates the velocity to the position? This is the only equation we have, v equal to dx over dt, cross multiply, and you integrate. When you integrate dx, you end up having what? Delta x. When you integrate v dt, first of all, you have to get the velocity equation from the previous part. Where is the velocity equation? Right there. So you have to plug in. It's a long equation. So make sure you copy it step by step. You have yourself v sub I, you have yourself 1/2 jt squared, you have yourself a sub I t. How do you now, right? And you have to integrate, right? You have to distribute the integral. How do you integrate v sub I? V sub I times the time. How do you integrate 1/2 jt squared? You have to add 1 to the exponent divided by the total number of exponents. So you have jt cubed divided by 3. Plus, how do you integrate a sub I t to the raised first power plus 1 divided by 2? 1 plus 1 is going to give you 2. Clean up everything. On the left side, you have x sub f minus x sub I. Move the x sub I to the other side of the equation, and you get the idea. This is your final equation for the position. For part B, I'm not going to hold you responsible for part B, everybody. Just submit an empty file. This is the end of the problem. We already went over it in the classroom, so I don't want to spend too much time on it. All right, let me just scroll down if you want to take a picture.